A deep space telescope just intercepted a signal that should not exist. These are not random whispers from the cosmos, but structured, unexplained phenomena emanating from hypergiant stars, the universe's most massive and volatile giants. By the end of this, you will understand 25 of the most baffling cosmic signals that are actively reshaping modern astronomy. Why does one star pulse with the rhythm of a heartbeat, and what created a spiral pattern in the void so perfect it defies nature? What do you believe is waiting for us in the dark? Our journey begins not in the silent void, but close to home with a ghost. The Vela supernova remnant is the expanding debris cloud from a star that died millennia ago, a cosmic graveyard we thought we understood. Yet from within this nebular tomb, a new signal pulses with stubborn regularity. This is not the familiar spin of a pulsar, the dead star's rapidly rotating core. It is something else entirely, a repeating radio burst that defies all known classifications. Its frequency is unique, a specific radio wave signature that does not match the profile of any known magnetar or other stellar corpse. Astronomers have pointed their most sensitive instruments toward it, running through every known catalogue of celestial objects, and each time the result is the same. No match found. The very fact that it originates so close to a known, well-studied stellar remnant is what makes it so deeply baffling. It is like hearing a steady, unfamiliar heartbeat coming from a grave you have visited for years, a persistent rhythm from a source that by all rights should be utterly silent. What could possibly be generating this energy within a field of stellar ash? That ghostly heartbeat from a dead star is just the beginning. Far from the silent graveyards of supernova remnants, a living star is sending out its own rhythmic cry, a signal that speaks of imminent and violent transformation. Eta Carinii is a hypergiant, a true titan of our galaxy, so unstable that astronomers have long expected it to explode. Yet its most fascinating feature is not its brilliant, chaotic light, but a slow, steady pulse of X-rays that beats from its core with the precision of a clock. This is not the erratic shuddering of a dying star. It is a deep, resonant heartbeat that seems to predict the star's convulsions, flaring in a regular rhythm that current models of stellar instability cannot explain. How can a star on the verge of tearing itself apart exhibit such perfect timing? One compelling theory points to a hidden dance partner. Eta Carinii may not be alone. It could be locked in a gravitational embrace with a binary companion, a smaller, denser star whose periodic orbits stir the hypergiant's internal fires, creating this predictable pulse. Each time this unseen companion swings close, it could trigger immense eruptions in the larger star, a celestial metronome counting down to an inevitable supernova. Alternatively, the rhythm may be generated from within, a consequence of internal processes we have not yet begun to model. Imagine a star so massive that its own core layers slosh and oscillate like water in a colossal basin, creating resonant frequencies that manifest as these powerful X-ray beats. This stellar heartbeat is a countdown, but to what? It is a mystery written in the language of radiation, a signal from a star screaming its final secrets into the void. The rhythmic heartbeat of a doomed star is one thing, but what happens when a cosmic titan simply blinks? Betelgeuse, the familiar red giant in Orion's shoulder, captured the world's attention when it dramatically faded, dimming to a fraction of its usual brilliance in a matter of months. This event alone was a stellar mystery, but the real enigma arrived in its wake. As telescopes watched the star's light recover, a separate network of radio observatories detected something entirely unexpected. It was not a simple echo of the dimming event, a rebound of the vanished light. Instead, a strange radio signal washed over Earth, a signal that contained modulated patterns, subtle but distinct variations in its frequency and amplitude. This was not random stellar noise, it was structured. The immediate and most conservative explanation pointed to the vast clouds of dust expelled during the dimming episode. Perhaps as this dust cooled and swirled, it interacted with Betelgeuse's powerful magnetic fields in a way that imprinted these curious modulations onto the radio waves. But the specific patterns observed do not fit neatly into any known model of dust and plasma interaction. This misfit opens the door to far more exotic possibilities. Could the signal be a direct transmission from the star's convulsing interior, a coded message of its internal upheaval? Betelgeuse is a colossal, roiling ball of plasma, and its great dimming is believed to have been caused by a massive ejection of material from its surface. What if that internal trauma, the sloshing of its deep convective layers and the shuddering of its core, generated resonant frequencies that were then broadcast into space as this patterned radio cry? We are essentially listening to the groans of a star's internal architecture under immense stress, a structure we can only theorize about from a safe distance. The signal from Betelgeuse is a whisper from the heart of a giant, a whisper that suggests our maps of stellar interiors are still woefully incomplete. The groans of a dying giant are one thing, but what about a star that is actively writing its own epitaph in the sky? Far across the galaxy, the Wolf-Rayet star known as WR104 is doing exactly that, and the message it is sending is a spiral, a vast, rotating pinwheel of infrared and radio energy so geometrically perfect it seems to defy the chaotic nature of the cosmos. This is not a faint, scribbled signature. It is a brilliant, luminous spiral that unfolds across space with the precise regularity of a celestial clockwork. Most stellar emissions are messy, turbulent clouds of gas and radiation, the predictable result of violent but random stellar winds. The signal from WR104 is different. Its structure is flawless, a near-perfect Archimedean spiral that rotates once every 8 months, a pattern so clean and consistent it looks almost engineered. The leading natural explanation is a complex gravitational dance. WR104 is a binary system with a massive Wolf-Rayet star and a hot, blue companion star locked in a tight orbit. As the Wolf-Rayet star sheds its outer layers in a furious stellar wind, its companion star plows through this outflow. The interaction between these two powerful winds is thought to be sculpted by their orbital motion, twisting the ejected material into that breathtaking spiral pattern which we see glowing in infrared light. It is a natural explanation, yet the sheer perfection of the spiral continues to spark intense debate. The pattern is mathematically so precise that some researchers have quietly wondered if we are seeing something more than just a stellar phenomenon. Could a structure this ordered be the signature of a technology, a vast cosmic artifact or beacon designed to be noticed across interstellar distances? This is, of course, highly speculative, but the very fact that the question can be seriously contemplated highlights how deeply unusual this signal truly is. It forces us to confront a fundamental question about our universe. Where do we draw the line between a supremely complex natural process and something that was intentionally made? The spiral of WR104 is a riddle written in fire and light, a cosmic message whose author remains unknown. The spiral of WR104 is a cosmic masterpiece, but other giants communicate through sudden, violent silence. Our Coronary Borealis is a hypergiant with a peculiar habit. It periodically fades from view, dimming so dramatically it almost vanishes from the sky for months at a time. These are not gentle fluctuations, they are stellar blackouts, and we now know they are preceded by a frantic final shout. Just before the star's light plunges into obscurity, a powerful, short-duration radio burst erupts from its surface. These are not the long, rhythmic pulses of Eta Carinii. They are sharp, explosive cracks of energy, a brilliant flash that screams into the darkness an instant before the curtain falls. The leading explanation points to the star's unique composition. Our Coronae Borealis is a carbon star, so rich in that element that it periodically belches vast clouds of carbon soot into space. The prevailing theory suggests that just before one of these ejection events, titanic pressures build up beneath the star's surface. The radio burst could be the sound of that shell cracking, the final moment of release as a cloud of carbon is blasted free, a cloud that then expands and cools, forming a shroud that blocks the star's light from our view. It is a logical, almost elegant sequence, a build-up, a rupture, an ejection, and a dimming. Yet this simple story is complicated by the signal itself. The energy profile of these pre-blackout bursts is bizarrely unique. They occupy a specific, narrow band of the radio spectrum with a polarization and frequency spread that does not match any known model of stellar matter ejection. If it were simply gas and dust being pushed away, we would expect a messier, broader signal. What we detect is something far more focused and energetic. This forces a difficult question. What physical process inside a star can create such a clean, powerful radio spike? Could it be generated by a sudden reorganization of the star's immense magnetic field, snapping like a rubber band as the carbon cloud detaches? Or does it signal the formation of something more exotic in those final moments before the ejection, like a brief, intense shockwave traveling through the star's outer layers at nearly the speed of light? These blackout bursts are a stellar alarm clock, ringing a single, sharp bell to announce an impending darkness. But the precise mechanism of that bell, its unique and pure tone, remains one of the star's best-kept secrets. Two stars within the Perseus double cluster are broadcasting signals so strange they might be a conversation. This dense swarm of ancient giants is a stellar metropolis, and from its heart comes a constant, pervasive hum. It is Signal 6, a low-frequency drone that seems to emanate from the entire region at once, a vibrational backdrop to the cluster's brilliant light. This is not a sharp pulse or a rhythmic beat, but a continuous, almost subsonic presence, like the deep, resonant note of a massive power generator heard from a great distance. Identifying its source is nearly impossible because the hum is everywhere, saturating the space between the stars. It could be the collective, blended sound of 1,000 hypergiant stellar winds crashing into one another, their combined turbulence creating a unified, low-energy signature. Or perhaps it is something far stranger, a fundamental oscillation of the cluster's shared gravitational field, a bass note from the fabric of spacetime itself, plucked by the immense combined mass of all those stars. This hum is the cluster's ambient noise, the sound of the city. Yet from within that same urban sprawl of stars, a single hypergiant sends out a signal that could not be more different. Signal 7 is a series of rapid, laser-like pulses in optical light. They are not the broad, chaotic flickering of a variable star. These are sharp, coherent flashes, incredibly brief and startlingly regular, like a super-powered lighthouse beacon cutting through a thick fog. The precision is baffling. What natural process could create such clean, rapid pulses of light from a single, roiling ball of plasma? One possibility involves stellar quakes, where the star's surface oscillates in a way that focuses its light into brief, intense releases. Another, more speculative idea points to a natural laser, a process called stimulated emission, where light is amplified within a cloud of excited gas around the star, creating those coherent bursts. The profound challenge for astronomers is determining if these two signals are separate anomalies or parts of a single, interconnected event. Is the hypergiant sending the laser pulses somehow generating the pervasive hum, its immense energy output vibrating the entire local medium? Or is the hum the cause, its constant low-frequency energy shaking the star and triggering the regular optical outbursts, like a steady vibration causing a bell to ring at a specific pitch? In the crowded stellar environment of the double cluster, we are left with a cosmic detective story, trying to decipher if we are hearing one complex phenomenon or two separate voices talking over each other in a crowded room. The crowded stellar metropolis of the Perseus double cluster gives way to a more isolated yet equally mysterious cosmic neighborhood. Orbiting the hypergiant star HD 226,868 is an invisible companion so dense that not even light can escape its grip. This is Cygnus X1, one of the first confirmed black holes in our galaxy, and the source of not one, but three distinct and baffling signals that seem to defy the simple rules of gravity and accretion. Signal 8 is a persistent rhythmic flicker in high-energy gamma rays. It pulses with a steady period, a rapid-fire beat of the universe's most powerful photons. The baffling part is that this rhythm does not match the known orbital period of the black hole and its stellar partner. If the flicker were caused by a clump of material falling from the star onto the black hole, its timing should be locked to their 5.6-day dance. Yet this gamma-ray metronome ticks to its own faster clock, entirely independent of the binary orbit. It is as if something within the black hole's violent accretion disk, the swirling maelstrom of superheated matter spiraling inward, is generating its own internal heartbeat. This suggests structures within the disk itself, perhaps massive waves or dents, orbiting clumps of gas that periodically eclipse our view, creating a pulse that is governed by the disk's own complex physics, a rhythm born from chaos. Then came Signal 9, a solitary event that broke the established patterns. A brilliant, unexplained flash of ultraviolet light erupted from the system, a burst of energy so intense it saturated the detectors. This was not a gradual brightening. It was a sudden, singular spike, a cosmic camera flash that occurred completely independently of any change in the system's X-ray output, which typically tracks the rate of matter falling into the black hole. The star was stable, the accretion flow was unchanged, yet something produced a massive, short-lived burst of UV radiation. One theory posits a magnetic reconnection event within the star's own atmosphere, a stellar flare of unimaginable scale. Another, more exotic possibility involves the black hole's own magnetic field, which is thought to be incredibly powerful and twisted. Perhaps a knot in this field suddenly snapped, releasing a colossal wave of energy that manifested as that brilliant ultraviolet flash. But the most profound mystery is Signal 10. While telescopes were monitoring the system's powerful X-ray emissions, a separate radio observatory detected something extraordinary. A series of structured radio waves, subtle modulations in frequency, appeared to be responding to the X-ray flares. It was not a simple echo. The radio signals would arrive with a slight, consistent delay after an X-ray burst, as if the system were communicating with itself across different energy bands. This deep space radio wave seems to be answering the X-ray emissions. One leading hypothesis points to a complex chain reaction. When a surge of matter falls onto the black hole, creating an X-ray flare, it might also trigger the launch of a jet of particles traveling at near light speed. This jet, plowing through the surrounding interstellar medium, could then generate those answering radio waves. The precise timing and structure of these responses, however, fuel theories about advanced accretion disk physics we are only beginning to grasp, or even other unknown high-energy processes involving the black hole's spin and its immense gravitational field. Together, these three signals paint a portrait of a system that is far more complex and dynamically interconnected than a simple star feeding a black hole. We are witnessing a cosmic conversation between gravity, matter, and light, a conversation where we are only just beginning to understand the language. The cosmic conversation near Cygnus X1 reveals a universe of immense complexity, but some signals are not just complex, they are unnaturally focused. Far away in the tail of the Scorpius constellation, the hypergiant star Pisces 24-1 is broadcasting a signal of such extreme intensity and precision that it challenges our very definition of a natural laser. This is Signal 11, a megamaser, a microwave laser on a cosmic scale. A natural maser, much like a laser but using microwave radiation instead of light, is a known phenomenon. It occurs when molecules, often water or hydroxyl, in a cloud of gas become energized and emit microwave radiation in a coordinated way. They are the celestial equivalent of a crowd whispering, creating a faint, diffuse glow. The signal from PSME's 24.1 is something else entirely. It is not a whisper, it is a scream. Its power is orders of magnitude greater than any stellar maser we have ever recorded, and its beam is incredibly narrow and structured, as if focused by a lens of astronomical proportions. This is not the broad, messy emission from a turbulent gas cloud. It is a clean, coherent spike of microwave energy that seems almost engineered. The immediate question is, what could possibly be powering this stellar spotlight? One line of investigation points to the star's extreme environment. PSME's 24.1 is a monster, one of the most massive stars known, blasting its surroundings with unimaginably powerful ultraviolet radiation and stellar winds. This energy could be pumping a nearby cloud of molecules, driving them into an extreme state of excitation that results in this super-powered maser. It would be like using a hurricane to power a single, perfectly tuned whistle. Another theory suggests we are witnessing a new type of astrophysical engine altogether, a natural laser that operates on principles we have not yet discovered, perhaps involving exotic molecules or a unique magnetic field configuration that collimates the beam. The sheer intensity and focus force a more profound question. Could a natural process truly create a signal this precise, or are we seeing the signature of a technology, a beacon designed to be noticed across the galactic void? The megamaser from PSME's 24.1 stands as a stark reminder that sometimes the universe does not just break the rules, it rewrites them entirely, presenting us with a phenomenon that sits squarely on the boundary between the natural world and something we do not yet understand. While the megamaser from PSME's 24.1 was unnervingly precise, other hypergiants communicate through sheer, unrestrained violence. The star known as LBV 18620, a luminous blue variable, did not send a subtle signal. It detonated on December 27, 2004, a wave of energy of almost incomprehensible power swept through our solar system. This was Signal 12, a hyperflare of gamma rays so colossal that it briefly overwhelmed satellites and for a fleeting moment physically altered our own planet. The burst was so intense that it actually ionized Earth's upper atmosphere, a feat normally reserved for the Sun during its most powerful solar storms. Yet this event originated over 40,000 light-years away from a single, distant star. The energy released in a fraction of a second dwarfed the total output of our Sun over hundreds of thousands of years. The scale is what left astronomers utterly stunned. Our Sun can produce powerful flares, but this event was orders of magnitude, perhaps 100 million times, stronger than anything our local star could ever muster. How could a single star unleash such a cataclysm? The debate over its origin fractures scientific opinion into two distinct camps. One group argues this was a statistical inevitability, a 1 in a billion stellar event. In this scenario, LBV 18620, already a notoriously unstable class of star, experienced a perfect storm of internal instabilities. Perhaps its immense magnetic field, tangled and stressed beyond its breaking point, suddenly and catastrophically reconfigured itself in a process called a magnetar-like flare, releasing a vast portion of its stored energy in one single apocalyptic burst. It was a stellar seizure of unprecedented magnitude. The other, more unsettling theory suggests this was not a fluke. It could be a sign of a previously unrecognized explosive phase in the life of the most massive stars. Luminous blue variables are already ticking time bombs, known for their giant eruptions where they shed entire solar masses of material. What if the hyperflare from LBV 1800620 was a new type of eruption, one that focuses its energy not into ejecting mass, but into a single, directed blast of radiation? This would mean that hypergiants do not just die in supernova, they can also fire off these cosmic ray guns, broadcasting their final agony across entire galaxies. The echo of that blast is a sobering reminder of the raw power slumbering within these stellar titans, and a question that hangs in the air long after the detectors stopped ringing. Was this a singular, freak accident, or have we just witnessed a standard, if terrifying, feature of a hypergiant's final act? The violence of a hyperflare is immense, but it is a sudden, singular blast. Other hypergiants reveal their instability through slower, more methodical forms of self-destruction. The yellow hypergiant Rho Cassiopeiae is one such star, and its signal is a scream written in the wind. Astronomers analyzing its spectrum, the unique fingerprint of its light, discovered something extraordinary embedded within the data. It was not a simple, steady flow of gas. Instead, they saw a series of sharp, periodic structures like the ghostly echoes of invisible explosions. These are not the chaotic fluctuations of a turbulent atmosphere. They are distinct, repeating signatures that resemble the sonic booms from an immense, unseen eruption. Picture the shockwave from a supersonic jet, a sharp pressure front that ripples through the air. Rho Cassiopeiae appears to be generating similar phenomena on a cosmic scale, but instead of sound, these are titanic pressure waves racing through its own stellar wind, the torrent of particles constantly flowing from its surface. Each of these spectral signatures marks the aftermath of a colossal event deep within the star, a convulsion so powerful it launches a shell of material at tremendous speed. This shell then rams into the slower-moving stellar wind that preceded it, creating a shock front that we detect as a sharp feature in the star's spectrum. The sheer scale is difficult to comprehend. Each of these events likely ejects more mass than our entire sun, all in a single, explosive pulse. This rhythmic, boom-like signal directly challenges our fundamental understanding of how these volatile stars lose mass. The standard model suggests a relatively steady, continuous outflow like a constant breeze. Rho Cassiopeiae operates differently. It does not breathe out, it coughs, experiencing violent, episodic eruptions that punch holes in its own atmosphere. What internal mechanism could possibly build up and release pressure with such regular, destructive force? Is the star's core pulsing in a way we cannot see, driving these rhythmic explosions from within? Or is its outer layer so unstable that it periodically reaches a breaking point, shedding entire continents of its own body into space? These sonic booms in the void are the death throes of a giant, played out not in a final supernova, but in a series of rehearsals that are rewriting the script of stellar evolution. A preemptive scream echoed from a star that refused to die. The blue supergiant SHER-25, a resident of a distant star cluster, sent a signal that was meant to be a final farewell, a signature of stellar death. Neutrinos, those ghostly particles that barely interact with matter, flooded out from the star's core, followed closely by a powerful, short-lived burst of radio waves. This specific combination, a neutrino flash paired with a radio cry, is the unmistakable fingerprint of a core collapse supernova. It is the universe's official death certificate for a massive star. Astronomers who detected it braced for the inevitable, training every available telescope on SHER-25, waiting for the brilliant fireball that would rip the star apart and light up the sky for weeks. But the explosion never came. The star simply carried on, shining as if nothing had happened. The death certificate had been issued for a patient who was, against all known laws of stellar physics, still very much alive. This left astronomers with a profound and unsettling puzzle. What internal cataclysm could possibly produce the very signals of total self-destruction without actually following through? One theory suggests a failed supernova, A fizzled detonation where the star's core did begin to collapse, generating the neutrino burst and sending a shockwave racing outward. But instead of blowing the star to pieces, this shockwave lost energy, stalling within the stellar layers and never reaching the surface. The radio burst could have been the sound of that shockwave hitting a dense shell of previously ejected material, a final, aborted cry. It was a stellar engine that turned over but never started. Another, more radical idea is that we witnessed a near miss, a stellar core that teetered on the very brink of collapse, perhaps even forming a proto-neutron star for a brief, terrifying moment before somehow stabilizing. The neutrinos were the scream of that near-death experience, a wave of panic from the core that somehow subsided. SHR-25's signal is a cosmic mystery that challenges our most fundamental assumptions about how stars die. It reveals that the final moments of a giant are not a simple, binary switch between life and a supernova, but a complex drama with acts we are only just beginning to see. What other false alarms are happening in the darkness, and how many times can a star cheat death before it finally succumbs? A star's final whisper is often written in dust. The post-red supergiant HD 179,821 is a star in its death throes, having ballooned to a colossal size and now shedding its outer layers in a slow, mournful wind. It is within this gentle outflow that astronomers detected the 15th signal, a faint but impossibly complex pattern woven into the star's infrared light. This is not a simple, steady glow from warm dust. It is a subtle, layered modulation, a series of delicate ripples and periodic dimmings that suggest a hidden architecture surrounding the dying giant. The infrared whisper tells a story of intricate dust shells, not one, but many, nested within each other like the layers of a cosmic onion. Each shell is a fossilized record of a past eruption, a time when the star violently coughed a layer of material into space. The modulations in the light occur as the star's radiation passes through these complex structures, with different wavelengths being absorbed and re-emitted in an intricate dance. The pattern is so detailed it implies these shells are not smooth and featureless. They are rippled, braided, and sculpted into shapes that speak of repeated, rhythmic activity. But the most baffling part of the signal points to something even more improbable. Embedded within the infrared modulation are hints of something large and solid orbiting perilously close to the star. The data suggests the presence of a massive body, perhaps a planet or a brown dwarf, that should have been utterly destroyed during the star's red supergiant phase. When HD 179,821 expanded, it would have engulfed everything in its inner system, vaporizing any worlds that once called it home. The existence of such an object now is a direct violation of our models of stellar evolution. How could anything survive that stellar inferno? One radical theory suggests this is not a survivor but a newborn. The complex dust shells might be dense enough and the conditions right for the gravitational coalescence of new planetary bodies from the ashes of the old star. We may be witnessing the birth of a second-generation planet, a phoenix world rising from the circumstellar debris. Alternatively, the orbiting body could be the stripped core of a much larger gas giant, a charred remnant that somehow endured the star's expansion. The faint infrared whisper from HD 179,821 is a testament to the hidden complexity of stellar death, suggesting that the final chapters of a star's life are not about simple dissipation, but about the creation of new, unexpected structures from the ruins of the old. Deep within the gravitational chaos of the galactic core, where stars swarm in a frantic dance around a supermassive black hole, two hypergiants are sending signals that hint at a cosmic conversation. Signal 16 is a ghostly ripple, a vast, slow-moving wave of radio energy that propagates through the interstellar medium like a swell moving through an invisible ocean. This is not a sharp pulse or a focused beam. It is a broad, undulating front that takes months to pass by, a disturbance that seems to be traveling through the very fabric of space between the stars. The ripple speed is what makes it so strange. It moves far slower than the speed of light, a pace that suggests it is not the radiation itself, but a physical wave pushing through the tenuous gas and dust that fills the void. One compelling theory points to the central black hole, Sagittarius, a star. Its immense gravitational pull can sling entire stars on wildly eccentric orbits, and when one of these stars passes particularly close to another, the gravitational disturbance could launch a pressure wave through the surrounding medium. Another possibility is that this ripple is the aftermath of a silent, invisible event, like the gravitational echo from a star that collapsed directly into a black hole without a supernova, its final whimper creating a ripple in the pond of the galaxy. Then, adding another layer of mystery, comes Signal 17. Across the same crowded central region, multiple hypergiant stars have been observed emitting coordinated X-ray bursts. These are not random flares. Telescopes have recorded these powerful, short-lived eruptions occurring in a distinct sequence, one after another, as if a wave of energy were sweeping through the stellar neighborhood. The timing is too precise to be mere coincidence. It suggests these massive stars, separated by light years, are somehow connected. Could the slow radio ripple of Signal 16 be the trigger? Its passing wave, front-compressing magnetic fields or stirring up interstellar plasma in a way that ignites these hypergiants like a chain of cosmic firecrackers. Or is the influence even more profound? The central supermassive black hole's titanic gravity warps the space around it, and its active states could be bathing the entire region in radiation or gravitational forces that cause these massive, unstable stars to flare in unison. We are potentially witnessing a galaxy-scale phenomenon, where the heart of the Milky Way itself is conducting an orchestra of stellar giants, a symphony of energy whose first notes we are only just beginning to hear. This stellar metronome beats with a rhythm that defies its own chaotic nature. The luminous blue variable Doradus is famous for its wild, unpredictable swings in brightness, a star known for its volatile temperament and giant eruptions. Yet beneath this apparent chaos, astronomers have detected a signal of stunning precision. It is a clock-like oscillation, a steady, repeating pulse that simultaneously modulates the star's visible light and its radio emissions. The paradox is profound. How can a star renowned for its erratic behavior host such a perfect internal timer? The oscillation is too regular to be caused by the random convective bubbles or turbulent flares that typically dominate a hypergiant's life. It points instead to a deep-seated, rhythmic process, a heartbeat within the hurricane. One compelling theory suggests hidden pulsations. Doradus may be undergoing subtle, periodic expansions and contractions of its entire structure, a breathing motion on a colossal scale. These radial pulsations could be driven by the star's immense gravity wrestling with the outward pressure of its radiation, creating a stable standing wave that resonates through its vast atmosphere. Each pulse would slightly change the star's temperature and size, accounting for the rhythmic change in brightness, while also disturbing its extended outer layers to generate the coordinated radio pulse. Another explanation involves the star's magnetic field, a potentially complex and powerful structure buried within the maelstrom. If this field is tilted or has a specific, stable configuration, the star's rotation could bring a magnetic hotspot into and out of our view periodically, creating the oscillation. The challenge is that luminous blue variables are not supposed to have such orderly, strong magnetic fields. Their interiors are thought to be too turbulent to sustain them. This signal forces us to reconsider what lies beneath the surface of these titans. Perhaps the most intriguing possibility is that we are witnessing a resonant frequency. Every physical object has a natural frequency at which it tends to vibrate. For a star as massive as Doradus, this frequency would be incredibly slow and deep. The oscillation we see could be the star literally ringing like a bell. its entire colossal form vibrating in a fundamental mode after being struck by internal convulsions or the accretion of a close-in companion. This resonant hum would then orchestrate the behavior of the outer atmosphere, synchronizing the release of light and radio waves into the steady beat we observe. The S Doradus oscillation is a secret order hidden within apparent chaos, a reminder that even the most volatile giants in the cosmos might still move to a hidden, universal music. The hidden rhythm of a volatile star is one thing, but what happens when a hypergiant's atmosphere reveals an element that should not be there? The star known as IRC plus 10,420 is a massive, aging hypergiant, a factory for forging the heavy elements that will one day seed new solar systems. Its spectrum, the chemical barcode of its light, should follow a predictable recipe with certain elements appearing in specific proportions based on our models of stellar interiors. Yet one line in that barcode blazes with impossible intensity, a signal so strong it defies all expectations. This is the phosphorus line anomaly, a stark, bright signature in the star's spectrum indicating a colossal overabundance of phosphorus gas in its outer atmosphere. This discovery sent shockwaves through the field of stellar physics because phosphorus is a fragile element, one that is created deep within a star's core under immense pressure and temperature. According to every established model, it should remain locked away in those central regions, not be found billowing in the star's outer winds. It is the equivalent of finding the molten iron from a factory's core smelting operation wafting through the air in the employee parking lot, a fundamental violation of the expected order. How did it get there? One radical theory suggests we are witnessing a previously unknown nucleosynthesis process. Perhaps in the extreme, turbulent conditions of a hypergiant's final evolutionary stages, a new type of nuclear reaction is occurring not in the core, but in the outer layers, a process that can forge phosphorus in situ. This would mean our maps of stellar chemical factories are incomplete, that these giants can create heavy elements in their atmospheres through mechanisms we have not yet dreamed of. The more widely debated explanation, however, involves a massive stellar conveyor belt. The interior of IRC plus 10,420 may be so violently unstable that powerful currents of plasma are physically dredging material up from the profound depths of the core, transporting it all the way to the surface where it is then ejected into space by the star's fierce winds. This would require a mixing process of unbelievable efficiency and power, a churning motion on a scale that challenges our understanding of fluid dynamics inside stars. The sheer strength of the phosphorus line suggests this is not a minor leak, but a full-scale excavation. This anomaly forces a profound question about the life cycle of the most massive stars. Are they not just creators of elements, but also cosmic distributors? Using internal machinery, we are only beginning to glimpse to scatter newly forged atoms directly into the galaxy. The phosphorus signal is a single, bright clue pointing to a hidden engine deep within the heart of a giant, an engine that is actively rewriting the periodic table in its own sky. The colossal hypergiant V Canis Majoris does not just shine or pulse, it seems to speak. From the turbulent depths of this dying leviathan comes the 20th signal, a complex, almost conversational pattern of microwave emissions that dances on the very edge of coherence. What we detect is not a simple, random hiss of stellar noise. It is a sequence of modulated bursts with variations in amplitude and frequency that create a distinct quasi-linguistic rhythm, a cadence that feels unnervingly structured to the human ear. The signal ebbs and flows in a way that mimics the pauses and emphases of spoken language, a natural stochastic phenomenon that, by sheer chance, has arranged itself into a form that resonates with our own deepest patterns of communication. For researchers in the search for extraterrestrial intelligence, this signal is a tantalizing, though likely accidental, muse. It represents the kind of complex, non-repeating structure they might one day hope to find from a technological source, a benchmark for what a natural universe can produce that merely sounds intelligent. For astrophysicists, however, it presents a serious and profound puzzle. How can the ostensibly chaotic atmosphere of a hypergiant star, a maelstrom of superheated plasma and titanic magnetic storms, generate such intricate modulation? The leading hypothesis delves into the physics of immense shock waves. Why Canis Majoris is violently shedding its mass, ejecting entire worlds' worth of material in colossal eruptions. As these giant clouds of gas are blasted outward, they crash into each other and into the slower-moving stellar wind. These collisions create vast, rippling shock fronts that travel through the circumstellar envelope. It is the complex interference of these countless shock waves, their overlapping and reinforcing patterns, that may be sculpting the raw microwave radiation into this strangely speech-like signal. Imagine the sound of a massive waterfall, a constant roar that, from a distance, resolves into what seems like a murmur of countless voices. We are essentially hearing the statistical echo of a star tearing itself apart, a sonic illusion born from layered, natural violence. Yet the sheer complexity of the pattern forces a humbling question. Are we, in our search for order, simply finding faces in the clouds of a stellar storm? Or does this signal point to a level of atmospheric physics so complex that its turbulence generates a fleeting, accidental grammar? The voice of Vy Canis Majoris is a whisper from a chaotic giant, a reminder that the line between random noise and meaningful structure may be thinner and far more beautiful than we ever suspected. The voice of a chaotic giant fades, replaced by a whisper from the deep past. Near the galactic center, the Pistol Star, one of the most luminous hypergiants ever discovered, is speaking to us through its own ghost. This 21st signal is not a direct transmission, but a series of delayed light echoes, celestial ripples carrying a message from a time long gone. We are not seeing the star as it is now, but as it was centuries ago, its ancient light having traveled to a distant dust cloud and now bouncing back to us like a cosmic echo in a cavern. The light itself tells a story of violence, revealing the spectral fingerprint of massive eruptions, periods when the star blew off colossal portions of its own atmosphere. Yet the chemical story written in that ancient light is the real mystery. The spectral information carried by these echoes does not match the star's current state, and it flatly contradicts our models of its historical mass loss. The ratios of certain elements, the specific signatures of hydrogen and helium, suggest the Pistol Star was shedding mass in a way that was far more violent and chemically complex than our simulations can reproduce. It is as if we found a fossilized footprint of a giant, but the shape of the foot is one we have never seen before. One leading theory is that we are witnessing the echo of a different type of stellar eruption altogether. Perhaps the Pistol Star did not lose its mass in a steady, predictable wind, but in a series of catastrophic, discrete blasts, each one peeling off a layer of its atmosphere and revealing a different chemical composition beneath. Each light echo could be the ghost of one of these apocalyptic sneezes, a fossilized snapshot of a stellar convulsion that our current telescopes, focused on the star's present calm, would never detect. This forces a profound revision of the star's life story. The Pistol Star may be far older or far younger than we ever estimated, its entire evolutionary timeline thrown into question by the chemical testimony of its own ancient light. We are essentially reading a history book about this star, only to discover that the chapters are in the wrong order and written in a language we do not fully understand. What other secrets are still traveling toward us, hidden in the light of echoes yet to arrive? A strobe light flashes in the deep, a frantic and alien rhythm against the silent backdrop of space. From the hypergiant Afgal 2298 comes a signal of pure ultraviolet fury, a rapid sequence of blinding flashes that pulse with the mechanical regularity of a cosmic beacon. These are not the slow, majestic pulses of a variable star. They are a frenetic strobe, a series of ultraviolet explosions repeating so quickly that they suggest an object locked in a punishingly tight orbit. The logic is simple. A celestial body whipping around the star every few hours would regularly eclipse our view or trigger an accretion flare, creating this rapid clockwork flicker. Yet this simple explanation shatters against physical reality. The orbit implied by this frequency is so close to the hypergiant's searing surface that no known object, not a planet, not a brown dwarf, not even a companion star, could possibly endure. The gravitational tides and the sheer radiative fury would tear any solid body apart and vaporize it into a wisp of plasma in an instant. So what then is casting this rhythmic shadow? What is triggering this impossible strobe? The answer may lie not in a separate object, but in the star's own tortured anatomy. One compelling theory proposes a massive magnetic slave, a colossal loop of magnetic energy rooted deep within the star. As the hypergiant rotates, this incredibly dense and powerful magnetic structure could sweep through its own outer atmosphere, compressing and superheating pockets of gas until they detonate in a brilliant ultraviolet flash with each pass. It would be a lighthouse whose lamp is not a beam of light but a traveling zone of stellar annihilation. Another, more unsettling idea is that we are witnessing the death throes of a world that ventured too close. Perhaps a gas giant spiraling inward over millennia has been stripped down to its incredibly dense core, a fragment of degenerate matter tough enough to withstand the stellar inferno for now. Its continued orbit through the star's extended atmosphere would create a constant, predictable series of shock waves, each one a flash in our ultraviolet detectors. This would be a dead world's core dancing in the fire of its executioner, signaling its own demise with every searing step. The AFGL 2298 strobe is a paradox, a signal that points to an orbit where nothing should be able to orbit, forcing us to choose between a new form of stellar instability or the ghost of a planet that refuses to die. The frantic ultraviolet strobe of a dying world gives way to a vision of cosmic perfection. From the star MWC 349 emerges a signal of breathtaking order, a spiral of microwave radiation so geometrically flawless it seems to defy the very nature of stellar chaos. This is not a random cloud of excited gas. It is a vast, rotating pinwheel of water maser emissions, a natural laser that traces out a structure of mathematical purity in the void. We have seen spirals before, like the one from WR104, but this one is different. It is not sculpted by the collision of two stellar winds. It is a single, coherent disk around one massive star, and its spiral arms are impossibly tight and well-defined. The rotation of a simple accretion disk, a flat pancake of swirling gas, should not be able to create such a sharply etched spiral pattern on its own. The physics of turbulence and random motion would blur the arms, turning them into a messy, indistinct smear. The perfection of this spiral demands a hidden architect, a force that can impose this level of order upon the chaos. One leading hypothesis points to an immense and perfectly ordered magnetic field. The star's magnetic field could be so strong and so structured that it acts like a cosmic comb, shepherding the excited water molecules into these precise curving lanes. As the disk rotates, the magnetic field lines frozen into the plasma could be wound up, pulling the gas into the beautiful spiral arms we observe. It would be a celestial fingerprint where the invisible lines of magnetic force leave a visible imprint on the light itself. Yet there is another, equally compelling possibility whispering from the data. This perfect spiral could be the gravitational signature of a hidden companion, a massive, dark object orbiting just beyond our sight. The gravity of this unseen partner would create a density wave within the disk, a ripple that moves through the gas like a wave through a crowd, compressing it into the permanent, rotating spiral pattern. The structure we see would then be a ghostly tracer, outlining the gravitational influence of something we cannot directly see. The signal from MWC 349 is a cosmic paradox, a phenomenon that sits at the boundary between known physics and something that feels almost designed. Its perfect geometry challenges us to look deeper, to question whether we are seeing the hand of a natural force we have yet to fully measure, or the subtle signature of a hidden dancer in the dark. This geometric perfection is humbling, yet other hypergiants communicate not through structure but through a chemical cry. The red hypergiant NML Cygni, one of the largest known stars in our galaxy, broadcasts a signal of immense complexity from within its own colossal atmosphere. Its spectrum, the chemical fingerprint of its light, is dominated by a dense, tangled forest of carbon monoxide lines. Normally, such a spectrum tells a story of a steady, expansive stellar wind, a predictable outflow of gas. But the forest from NML Cygni is not still. Individual lines within this chemical thicket are changing, and they are changing fast. Their intensities flicker and shift dramatically, and their velocities, which tell us whether gas is moving toward us or away, swing wildly. This is not the slow, stately flow of a stellar breeze. It is the signature of violent, localized explosions happening deep within the star's own extended body. Think of it like this: if a normal stellar wind is a steady river, the signal from NML Cygni is that same river suddenly punctuated by massive, underwater geysers erupting at random points, churning the water and sending powerful, isolated shockwaves in every direction. Each flickering carbon monoxide line is one of these geysers, a violent event in the star's envelope that ejects a clump of gas at tremendous speed. The standard model of stellar winds cannot explain this. It predicts a relatively smooth, homogeneous outflow, not this chaotic, internal shrapnel. So what is causing these violent convulsions? One theory points to pulsations. The star may be undergoing immense, rhythmic contractions and expansions, and when it contracts, it could be trapping radiation in its outer layers. The built-up pressure might then find release not in a gentle flow, but in sporadic, cannon-like blasts that punch through the atmosphere. Another, more radical idea involves the star's own chemistry. NML Cygni is rich in dust-forming elements. Perhaps vast clouds of dust are condensing deep inside its envelope, and when they form, they suddenly block the starlight. This creates a shadow, a drop in the outward radiation pressure that was holding the atmosphere up. The local gas, no longer supported, would then collapse inward under gravity, only to collide with other infalling material and rebound in a violent, localized explosion. We are essentially listening to the sound of a star's atmosphere falling in on itself in some places while violently erupting in others. A continuous state of internal turmoil that we never knew existed. The carbon monoxide forest is not a peaceful woodland, it is a battlefield, and each changing line is a flash from a separate, unseen explosion in a war raging within a giant. This final signal does not arrive as a flash or a pulse, but as a single, stubborn line in a star's chemical barcode. From the ancient Hypergiant SDSSJ 102,915 plus 172927, astronomers detected the unmistakable spectral signature of lithium. This discovery should have been a minor footnote, but instead it sent a tremor through the foundations of cosmology. The star is a cosmic fossil, one of the oldest and most metal-poor stars ever found, a relic from near the dawn of time. According to our most cherished models of stellar evolution and Big Bang nucleosynthesis, this star should have destroyed every last atom of its primordial lithium billions of years ago. Its core, a seething nuclear furnace, should have consumed the element entirely during the star's long life. The presence of lithium now is like finding a fresh, unburned log in the cold ashes of a fire that went out eons ago. It is a signal that defies the very timeline of stellar life and death. How could this fragile element have survived inside a star for over 13 billion years? The implications are staggering, forcing a direct confrontation with our understanding of the universe's first moments. The Big Bang produced a specific, predicted amount of lithium, and the oldest stars were supposed to be the pristine containers of that original recipe. This star's lithium signal tells us the recipe was wrong, or that something happened to these stellar containers that we never anticipated. One radical theory suggests that this hypergiant is not a first-generation star, but the product of a merger between two even older, lithium-rich stars, a cosmic accident that preserved the ancient element within its newly formed structure. Another, more profound idea is that our models of stellar interiors are fundamentally flawed for these primordial giants. Perhaps their cores are stratified in ways we do not understand, with layers that do not mix, creating quiet pockets where lithium could remain untouched by the central inferno. The signal from SDSS-J 102,915 plus 172927 is a whisper from the edge of time itself, a single chemical clue that our map of the universe's infancy is missing entire continents. It challenges us to rewrite the story of how the first stars lived and what they left behind. Lithium's whisper from the edge of time challenges our cosmic history, but these 25 signals together present a puzzle of a different magnitude. They force a confrontation with one of astronomy's oldest and most profound questions, the Fermi paradox. This is the stark contradiction between the high probability of alien civilizations and our utter lack of evidence for them. For decades, the search for extraterrestrial intelligence has operated on a hopeful assumption that a technological signal would stand out clearly against a backdrop of natural cosmic noise. Yet the symphony of hypergiants shatters that comforting idea. We are now surrounded by stellar heartbeats, perfect spirals, structured radio modulations, and signals that mimic language. If such complex, intricate, and seemingly ordered phenomena can be generated naturally by these volatile giants, then the cosmic haystack in which we are searching for the needle of intelligence has just become astronomically larger and far more tangled. Every strange pulse from a star like Eta Carinae, every geometric spiral from MWC 349 now becomes a potential false positive. How could we ever be certain that a signal is a technosignature, a deliberate broadcast, when the universe itself is capable of producing such stunningly complex emissions through natural physics alone? The great silence implied by the Fermi paradox may not be a silence at all. It might be a cacophony, a cosmic chorus of natural phenomena so advanced and intricate that they perfectly mimic the signatures we would expect from an intelligent, technological species. We have been listening for a shout in a quiet room, only to discover the room is actually a roaring concert hall. This realization does not make the search for extraterrestrial intelligence futile. Instead, it reframes the entire endeavor. The challenge is no longer simply to find a signal, but to understand the fundamental boundaries of natural astrophysics so deeply that we can recognize the one signal that steps beyond them. It forces a new discipline, one that must meticulously disentangle the language of stellar physics from a language that might be engineered. The unexplained signals from hypergiants are not just mysteries to be solved, they are the new baseline, the background static against which any true anomaly must now be measured. They have drawn a new, much fainter line in the sand between the natural and the artificial, daring us to find something that crosses it. These cosmic whispers will not remain mysteries for long. A new generation of eyes and ears is turning toward the sky, armed with technology that borders on the magical. The James Webb Space Telescope, already rewriting the rules of astronomy, is just the beginning. Its powerful infrared gaze can pierce the vast dust shroud around stars like HD 179821, seeing the intricate structure of those nested shells in stunning detail. It can analyze the chemical makeup of hypergiant winds with a precision we have never had before, potentially spotting the very conveyor belts that dredge phosphorus from stellar cores. But Webb is only one instrument in a coming symphony of discovery. On the ground, the Square Kilometre Array, or SCAR, will be a radio astronomer's dream. This is not a single telescope, but a vast network of thousands of antennae spread across 2 continents in South Africa and Australia. When complete, it will form a collective ear so sensitive it could detect airport radar on a planet orbiting a distant star. For hypergiant signals, this means something profound. The SKA will be able to map the complex radio modulations from stars like Betelgeuse or VY Canis Majoris in real time, untangling the overlapping shockwaves to see if they truly form a chaotic grammar. It could listen to the faint radio heartbeats of 1,000 hypergiants simultaneously, searching for patterns and connections we can only guess at today. And then there is LISA, the Laser Interferometer Space Antenna, a mission that will listen not for light but for the vibrations of space-time itself. LISA will consist of 3 spacecraft flying in a perfect triangle, millions of kilometers apart, connected by lasers. It is designed to detect gravitational waves, the ripples in the fabric of the universe caused by massive objects moving and colliding. This is the key to unlocking signals like the slow radio ripple from the galactic center. LISA could feel the gravitational echo of a star being torn apart by the central black hole, or sense the subtle orbital dance of a hidden companion around a star like AFGL 2229-8, confirming the source of its impossible strobe. Together, these observatories will not just collect more data, they will perceive the universe in entirely new ways. They will see chemistry, motion, and gravity as a unified story. The structured radio bursts, the perfect spirals, the chemical anomalies, all of these cosmic messages are about to be read with a clarity we have never before possessed. We are on the verge of not just hearing the giants, but finally understanding what they are trying to say. These 25 unexplained signals are more than just celestial curiosities. They are fundamental challenges to our understanding of physics itself. Each one represents a boundary being pushed. The ghostly heartbeat from the Vela supernova remnant forces us to question what can remain active in a stellar graveyard. The rhythmic X-ray cry of Eta Carinii and the groaning radio signal from Betelgeuse reveal that stellar interiors are far more complex and resonant than our models suggest. The perfect spiral of WR104 and the structured maser from MWC 349 present us with geometries so flawless they blur the line between natural formation and artificial design. The preemptive blackout bursts of R. Coronii Borealis and the failed death cry of SHER 25 show us that stellar death is not a simple, predictable switch, but a drama with acts we are only beginning to witness. The coordinated flares in the galactic center and the chaotic carbon monoxide forest of NML Cygni illustrate that stars are not isolated islands, but deeply interconnected participants in a galactic ecosystem. The impossible ultraviolet strobe of AFGL 2229-8 defies our understanding of orbital mechanics, while the ancient lithium whisper from SDSS J102915 rewrites the chemical history of the cosmos. Each signal, from the hyperflare of LBV 180620 to the conversational modulations of VY Canis Majoris, chips away at the foundations of our knowledge, revealing not what we know, but the vast, uncharted territory that remains. These hypergiants are not just distant suns, they are active laboratories of extreme physics, broadcasting their secrets in a language we are only just learning to decipher. Their collective message is one of profound humility. We have mapped the heavens, but we have only just begun to understand the voices of its most colossal inhabitants. So we turn the question to you, of these 25 cosmic mysteries, which signal captivates your imagination the most? Is it the stellar heartbeat, the perfect spiral, or the ghost from a dead star? Share your thoughts in the comments below and never stop looking up, for the next great secret of the universe is waiting to be heard.